Welcome to another video of our DBMS playlist. We were studying about normalization. So today we will learn about first normal form, that is 1NF. So let's start. So what is the rule for a table being in first NF or first normal form? So let's see. The table should not contain any multi-valued attribute. Okay, so what is a multi-valued attribute? So let's see. Suppose this is a table. Okay, so there are two students here, roll number 1 and 2. Their names are A and B, and roll number 1 have two courses, C and C++. Roll number 2 have only one course, DBMS, so that's not the problem. But see here, roll number 1 has two courses enrolled, C and C++. So this particular column have two values for a particular person. So this is known as multi-valued attribute. So this is not allowed in first normal form. So this table is not in first NF or first normal form. So how to make this table in first normal form? So see, there are few solutions here. So what we will take, let's check first. So this is first solution. Okay, so we can do what? We can repeat the row of student of roll number 1. Okay, so I have written the same row twice, and for the first row I have written the course as C, and for the second row I have written the course as C++, and after that we have the other row which we have same as before. Okay, so I have just divided this row into two different rows. So that, what is the problem here? The problem is the data redundancy. Okay, so these roll number and name values are repeating itself. So suppose if there was 5 courses, so there should be 5 same rows with same roll number and same name, so it will be just a waste of space. Okay, so this solution is denied. What is the other solution? We can do what? We can also make another different column. Okay, so what we were doing here, we were adding another row. Here we are adding another different column. So I have divided the course column into two parts, that is course 1 and course 2. So for student name A, there are two courses. For course 1 it is C, and for course 2 it is C++. But see, for student name 2, for student name B, there is only value in course 1, that is DBMS. He has no course 2, so it will be assigned with null. So suppose there were 10 courses. Okay, so there were 10 courses taken by value A or student name A. So then there should be 10 columns. Okay, and there should be many null values occurring inside our table. So this will also be a waste of space. Okay, so multiple null values is also not recommended. So this is also rejected. So what is the best solution we can do is to divide the table into two parts. Okay, and join them using our foreign key concept. So what is the foreign key concept? So this I have already taught in my SQL playlist. I will provide the link of the SQL playlist inside the description box, so you can check it. So let's see here. So we will divide this table. Okay, so this single table into two different tables. So this table will have roll number and name. Okay, and this table will have roll number and course. So here roll number is the primary key. Okay, and here this roll number will be acting as our foreign key. So what is this foreign key and primary key concepts? You will all get that from this playlist. Okay, from the SQL playlist. So check there. So now see, so this roll number 1 having two courses, C and C++. So see, there is the data repetition of the name column is ignored here. Okay, so the name is not written twice, only the roll number is being repeated. So it will save us some space. So and also the third column, that is the, say for the second student, the DBMS course, this remains exactly same. So this is the way to convert a table which is not in first NF to two different separate tables of first normal form. So now let's check something very important, that is closure method. So what is functional dependency? So first see what is a functional dependency or FD. So this functional dependency thing is known as the relationship between attributes of a table. Okay, attribute means columns. Okay, so there are different attributes or relationships between a table between the columns of a table. So these are known as functional dependencies or FDs. So this is a relation R ABCD, and the functional dependencies of this relation are this: A defines B. So how to read this? This is read as A defines B, B defines C, and C defines D. So these are the functional dependencies of our relation. So now let's check how to find the closure of A. Okay, so suppose we are finding closure of A. So A or any particular attribute can always define itself. So A will define A, and see from here we can see that A also defines B. So also we can see from our FD that B can define C. So as A can define B, then A can also define C, and similarly C is defining D. So A can define C, then A can also define D. So A can define both A, B, C, D, all of the attributes of our relation. So this means the closure of A is A, B, C, D, that is all the attributes inside our relation. Similarly, the closure of B is what? The closure of B is B, C and D. Okay, because B cannot define A. B can only define itself, and from B to C we have that B is defining C and B is also defining D. So similarly, after checking all the closures of A, B, C and D, we can find that only A is the single attribute we have which can define all the attributes of our relation. So the attribute which can define all the other attributes of our relation is known as the candidate key. So A is the candidate key here. Okay, so A is the candidate key of this relation. So again, see what we are using here. So suppose we are using A to B and we have B to C. So from here we can say that A can also define C. Okay, so this is the transitive property. So if A can define B and B can define C, then we can say that A can also define C. This property we used here, okay, for this particular closure, because A is the attribute which defines all the other attributes of the relation, then A is known as the candidate key. So the attribute which defines all other attributes of a relation is known as the candidate key. But there is also another thing to needed to be a candidate key. Okay, so from here we can see that the closure of AB plus, okay, suppose there is an attribute that is AB together, so the closure of AB is written as AB plus. So the closure of AB is also all the attributes here, is also the collection of all attributes A, B, C and D. But is AB also the candidate key? No, AB is not candidate key. Why? Because candidate key must be the minimal attribute. Okay, it must always be the minimum thing. Okay, it should always be minimum. So the minimum attribute which can define all other attributes of a relation is known as the candidate key. But then what? AB is what? AB is known as super key. Okay, so all the candidate keys are also super keys. So all the keys or all the attributes which can define every single attribute of the relation is known as super key. But if the super key is the minimal thing, okay, if the super key is the minimal thing, that is we cannot break the super key, or we cannot have any smaller key from that super key which is also a super key, then it is candidate key. So A is we can remove B from this super key also, and still we will be having our all the attributes of our relation. Okay, we can remove B and we will still be having that. So only the closure of A is the minimal thing here. Okay, so the closure of A is the minimal thing. So the closure of A is the minimal attribute which will be giving us all other attributes of our relation. So this is A here is known as the candidate key. So now we will check some new things, that is prime attributes and non-prime attributes. So what is prime attributes? The attributes used in making of candidate key is known as prime attributes, and the other attributes which are not prime attributes, these are called non-prime attributes. So don't worry, I will be giving you an example, and I will also teach you how to find the candidate key in a proper way.